Hi everyone, thanks for coming to the last session and not for disappearing into a pub yet. Give me 10 minutes or 15 or so. So today's topic is the brilliantly named container snap. Yes, I shouldn't be in charge of naming anything, but this is about the tech. So this is a tool that I wrote about deploying updates from OCI Images using Btrfs. The most boring part, who am I? I'm Dan. I'm a software developer working at SUSE for what feels like an eternity at this point. I started pre-pandemic, so that's the eternity. I also do stuff in Fedora, and in case you want to stalk me somewhere, you'll find links on my website, but I'm running out of time. So what's Atomic Updates? And why has this been the jazz all the time last year? So Atomic Updates are essentially updates to operating systems that that are either applied fully or not at all. And why do we care about that? Well, I guess if you've been using Linux long enough or long ago enough, then you ran DNF upgrade, yum upgrade, or apt-get upgrade, and some scriptlet dies at some point. And now your system is in this funny state where it's half upgraded and half not, and you have to recover it. And that's always especially a lot of fun if this is a production-grade system and it's Friday evening and you want to leave for the weekend or for your holiday, and now you got to fix it. And of course, the last backup has been done a week ago, and it doesn't include the root partition, so even more fun. So this is in principle a very nifty thing. Nowadays, so there's multiple names for this. I know OpenSUSE, where I kind of also hang my hat, calls this transactional updates. It's often also combined with immutable root partitions or with AB upgrades on Android. And yeah, there's many different ways. So next term, bootable containers. When I'm talking about bootable containers or deploying OSs from containers, I'm not talking about using or abusing our container runtime to launch VMs. This is really abusing the OCI image format for container images. And now you might ask yourself, why? Come on, it's a tar archive, there's better formats for that. And the answer is pretty simple. I can throw together a Docker file in a minute, maybe in 2, if I forget something. If I want to build a QCOV image, that's going to take a bit longer. So everyone knows how to build a container image. If you want to boot from it, then it gets a little bit trickier because you have to include additional stuff like a kernel, an init system, all the stuff that you usually leave out of a container image. But still, it's pretty simple to pull off. Building a real operating system QCOV image, you have to find the proper tool. There's about 50 of them. They have different config files, and I can't do it off the top of my head. And maybe all of you can, but, well, I can't. So, and many other developers are far more familiar with container images. And second thing, there's already a distribution mechanism, container registries. I'm not aware of anything that's really standardized for disk images, except for the now not so used anymore Vagrant Cloud, which was used to distribute Vagrant boxes. But Vagrant is now, well, HashiCorp changed its license, and now no one uses it anymore. So we're getting closer. We want to boot from OCI Images. How would we do that? We have our registry. Our registry serves our container images. And then we have some tool that could be bootc, or if you are crazy and you want to run my code, then you would run container snap. And that takes the contents of the image, applies it on your disk, and then you can boot from that. Sounds simple, it's pretty hairy in practice. Since I'm pretty lazy, I didn't want to write most of the code myself, and I used OpenSUSE's transactional update kit, or short TUI kit. Very quick summary of what this does. So this is OpenSUSE's implementation, default implementation for an immutable root partition, and it leverages Btrfs snapshots. So your root partition is mostly, your root partition is is formatted with Btrfs. All the important data are in a subvolume. And now if you want to, this subvolume is set as read-only, so you can't really mess with it. And if you want to create an upgrade, you create a new snapshot, because thankfully Btrfs supports that. You install your upgrade into the new snapshot, and then you reboot from that. And then it sets that one as read-only, and for that you can use this nice feature of setting the default subvolume, which essentially tells Btrfs, oh yeah, that's by the way your root partition now, and not the previous subvolume. Why do we really need that? So essentially the idea is now we will not upgrade using a package manager, because what happens here is you take the root partition, you make a new snapshot, you run Zypper up or DNF up or whatever your package manager is, and you run that in the new snapshot. And if in case that one breaks, you just trash it and nothing ever happened. And in case you find out the snapshot's busted, you can roll back. And the idea is now, okay, we are not going to create this snapshot from running Zypper up, but from a container image. We're getting closer. Next step, Podman's Btrfs driver. So Podman and container engines need a way to store the container images on disk. If you're using Podman, then it's most likely that you're not using the Btrfs driver, but you're using the overlay or overlay 2 driver, which is the one that's most tested. But there's still this one remnant from long, long ago. So in Kubernetes world, it's an eternity, so something like 10 years. And that one, I think, was copied over from Docker, but that's way before my time. And what it essentially does is it stores disk images under the graph root, which is just an internal Podman term. So it's in some directory. It must be Btrfs. And each container image is a single subvolume, and each container layer is created as a snapshot of the previous layer. That's actually the boring part. The important part is each container image is a single subvolume. And that means we can theoretically take this subvolume and tell Btrfs, oh, hey, this is your default subvolume now. So on next boot, this container image will appear as root, as what's written to root. And that's essentially it. So maybe 5 lines of code. Well, it's a little bit more because I didn't make just a single hacky shell script. And because I'm uncreative, I asked Gemini how to call it, and Gemini came up with container snap. And that's essentially it. So what this thing does is you give it a container image, pulls it down, it puts it into a Btrfs store. There your image lands as a Btrfs subvolume, and then I use TUI kit, so the transactional update kit, to customize it, tweak it a little bit, and then you can boot from it, and you can boot from a container image. And in case you're thinking, well, that sounds far too theoretical, I have made a demo, and since I'm not so crazy to run a live demo, I've pre-recorded it. Because the internet connection, yes, huh? Oh, wrong screen. Great job, Dan. That essentially is a VM. Pull down an image. Yeah, I need to work on the UI. Then you can check whether it's installed. Then you switch to it. That sets up the new Btrfs subvolume. Then you need to do a few manual steps, because this is just a few days hack week project, like copying your old F-step over, because otherwise all your mounts are gone. Resolve.conf, because you want networking. That's also pretty useful, otherwise your new snapshot doesn't work. And etc shadow is also useful if you want to log in again. So I didn't do that once, and then my root password is gone. Oops. Yeah, and then you need to do things like reinstall the bootloader, which was the only way to really get the thing to boot again. So that's also not very pretty. And yeah, so this is all run Drake-it and reinstall the bootloader, reboot, and you get presented with a very ugly grub2 screen, which is not the OpenSUSE default, and then you can log in. And that's essentially it. And now what's still left, and that is a lot. The main thing is actual usage, because this is a Hack Week project, and this is the first time I'm presenting this, and I have only run it in VMs, and it will probably break. So if you want to give it a try, pick a VM first. Also, etc handling is very ugly. As you've seen, it involves copying over files from your current system into the new snapshot, and you want to have certain files persisted across reboots properly and across images, because your container image usually includes stuff like etc shadow or etc fstep, but you don't want to take that from the container image registry. That's something that's really host specific. Also, the UX is not great. Need to work on that. And if you get a kernel update, you need to redo all those ugly steps, like reinstalling the bootloader, because that's currently the only way how to get that going. Also, I haven't been so far I've been testing it simply on OpenSUSE Tumbleweed and kind of converting a running Tumbleweed into one that uses container snap. I would like to eventually create a pre-built, pre-baked VM, but for that I'd need to add support to an image builder, and time is short, or has been short for that. Yeah, and you also need to patch transactional update kit, and my pull request has been rotting for half a year, so that needs to get finished as well. And then there's the action item for you. Take a look at it, and if you're feeling brave, give it a try. And to make it even easier for you, that's also the link. And I think I even have 2.5 minutes left, so thank you for your attention. And if there's any questions, feel free to ask them now, feel free to ask them later at the OpenSUSE booth, or just try to guess my email and send me an email or find me on Matrix. Thanks. Yes?
Why isn't just XC just like config to the new container?
Sorry.
Like when you do the switch,
Mm-hmm.
why don't you just like reuse the same XC?
Because so the question is why don't I reuse exactly the same etc? Because one of the programs might get an update along the time and might get a new config file. So essentially my current plan is to make this a bit future-proof, is that you select some config files that you want to persist, and to bind mount them from somewhere outside of this subvolume. So that's this Bindicate project that I linked in. That's in a very hacky early stage. Okay, then yeah. So what's the question? Okay, so question is what's the difference between the proper transactional updates as it's handled by OpenSUSE MicroOS and this one. So it's very similar because it uses the same tech. So transactional update on MicroOS does the same thing, only. So the big difference is with in MicroOS, you create a new snapshot and you run the upgrade by running Zypper up or Zypper dub in the new snapshot. With Container Snap, this snapshot is a new container image. In principle, it could be a completely different container image. You might even be able to switch distros if you're really crazy. Sorry, we are out of time, but you can find me also later. And thanks a lot.